So if you see the Arenes, mostly it's the reaction with the metals. So there are two. One is the Grignard reagent and the Woods reaction. So let's see what are they. So what is this Woods reaction is? It involves treating 2 moles of alkyl halides with the sodium metal. Okay, so that means you are treating the alkyl halides with the sodium metal and you are getting certain alkanes. That means you take alkyl halide and you treat that with some metal. Here we are taking the sodium. That will give an alkane. Okay, so that's a Woods reaction. So what happens in this? There is a 2 moles of alkyl halides treated with a metal that is sodium, and you will be getting the alkane here. So mostly it's a ether. So you will be getting at the end the dry ether. So remember this. In order to prepare this, you will be taking either the primary or secondary alkyl halides. So these alkyl halides could be the primary or secondary. So what is meaning of primary and secondary? You know, if it is attached to one carbon, it's a primary. If it is attached to two different carbons, it is called as secondary. And if you see the general reaction, it would happen something like this. So there is R and there is a X plus 2Na plus again there's a X, there is a R. So there will be bond formation happens between this halosine and the sodium. So X and sodium, they will react and form something. It could be chlorine, fluorine, bromine, iodine. So we know sodium and chlorine, it will give NaCl or NaBr. So something it will come like that. Okay. So this in presence of sodium, dry ether, that would be RR plus 2NaX. Understood? So how does the Woods reaction happens? So remember, Woods reaction in this method, what we are doing, we are taking 2 moles of this alkyl halide. So you can see here, this is the first mole and this is the second mole. So that 2 moles, you are reacting with a sodium metal. So when you are reacting the sodium metal in presence of dry ether, you are getting an alkane. Okay. Understood? Here, the alkyl halide could be the primary or secondary. Any doubts? So what is the Woods reaction?
No, sir.
Awesome. Good, good, good. Okay. So let's see different reactions of haloarenes. It could be the nucleophilic substitution or electrophilic substitution or reaction with the certain metals. Okay. So that's nothing but Woods reaction. So reaction with metals, it's somewhat like a Woods reaction. Okay. So first we'll see what is this nucleophilic aromatic substitution. So what happens here? A simply aryl halide or relatively unreactive towards the nucleophilic substitution under condition that would give rapid nucleophilic substitution with alkyl halides. Understood? What does that mean? Come on, guys, it's simple English. What it's saying is, first, suppose you take the similar conditions that are very favorable for the alkyl halides, those conditions are not suitable for the aryl halides. That's what it means. So see here, the aryl halides are relatively unreactive towards the nucleophilic substitution, those conditions which are very rapid for the alkyl halides. Understood? What it means? First, suppose, let me take an example here. So whatever the statement which I said here, for that, it's the example. So what happened here? The chlorobenzene, when you are eating, when you are boiled with a sodium hydroxide, and you are doing this for several days, but that is not producing any phenol here. So what actually happens? First, suppose you take the benzene ring that is attached to chlorine. So what is this? This is an aryl halide. And you are reacting with a NaOH. So we know this is a perfect example of aryl halide, and you are treating with a strong nucleophile. So we know that this nucleophile will replace this chlorine. So that's what the meaning of nucleophilic substitution. Yes or no? So when we reacted the same thing like CS3, CS2, Cl, here the chlorine is replaced with OH. So that aryl halide is turned into an alcohol. Yes or no? So that's how the SN reactions were happened. So what happening here? So when you are reacting this aryl halide chlorine and with NaOH, In the presence of water and heat, it is not producing any product. So there is no product here. So that's what he says. So detachable amount of phenol. So that means without producing any phenol here. Okay. So there is no substitution happened here. So remember this. So there is no substitution. You understood what is this example says? Any doubts?
No, sir.
Nitya, Mandara, you understood?
Yes.
So what is this statement says and what is the example say? How does the example is just relating this to this statement?
Yes, sir.
Okay. Okay. So next one. So let's see few things. So phenyl cations are very unstable. We know. So whenever the nucleophilic substitution reaction is happening for aliphatic, I told you one thing. It should form a strong cation. So whatever the carbocation it is forming, that carbocation should be very stable enough. So when it is stable, the reaction will proceed further and it will form the products. So there will be replacement of the nucleophile, and that's called the nucleophilic substitution will happen, but only when the carbocation is very stable. But here, the carbocation which is forming in the aromatic compounds, it is not stable at all. It is very reactive. So that's why this reaction doesn't try to happen. So that's why you saw this. So whatever the conditions that you are using for the alkyl halides, those conditions are not at all favorable for the aromatic compounds, for aryl halides. Understood? So phenyl cations are very unstable. So whatever the carbocation that is formed, it is very stable and the reaction will not happen. For suppose you can see here. So there is a aryl halide, or you say any example, halogens. So when you react this, so it will form a cation, but that cation is too much reactive, so that again it will try to combine with the halogen itself due to its very instability. So that's why the replacement of this nucleophile is very hard for aromatic compounds. Understood? So whenever this intermediate or carbocation is formed, it should be stable enough, then only the reaction will happen forward. Okay. Otherwise, this reaction will not move forward. Is this understood? So how does the nucleophilic aromatic substitution is regarding the unstable carbocation? Any doubts? Can I go next?
Yes.
Arey, tell yaar something
Yes.
yes or no.
Yes, sir.
Yeah. So next one. So the carbo-halogen bonds of aryl halides are shorter and stronger compared to the allyl allylic or benzylic. First, suppose if you take the alkyl halides, example like CS3, CS2, Cl. So if you see here, this bond is not too much stronger compared to the bond that's present between the aromatic compound and the chlorine or some halogen. So this is very, very strong. Here, whatever this bond is there, it is very strong. Whereas the bond present between this carbon and the chlorine, it is not that much strong. So that's why you can easily break this and you can form the carbocation. But breaking here the halogen bond with the aromatic compound, it is too much strong. So it will form a very unstable carbocation as well. Okay. So in order to break this bond, you remember it requires a lot of energy. Okay. So bond breaking, either you do whichever the reaction, either it's a SN1 or SN2. Okay. So bond breaking by either SN1 or SN2 requires a lot of energy. Okay. So remember this. That's what another difference for the aromatic compound compared to the aliphatic compounds. Understood? So for alkyl halides, whatever this bond is there, you can easily break it. You don't need to spend too much of energy. But in order to break the bond for this halogen and halides, you need a lot of energy. So that's why the bond breaking for SN1 or SN2 reaction, it's a not easy step. Clear? And why does that requires a very energy? Why this bond is too much strong? That's because of the thing called the resonance. Remember, whenever a compound is undergoing resonance, it becomes the strong, it becomes very stable. Okay. So you see here, whatever the halogen that contains the bond with this carbon, that can supply the electrons to this. So there can be the double bond can move electrons to the carbon that is present here. So this carbon will try to make the double bond here, and this double bond will break and it will shift to here. And this process will be continuously happening, and you will be seeing the different structure. So see here. So whatever the double bond it is present here, now it reached to the carbon that's present here. So and then this carbon, which is having electrons, it has turned here. So that's how it created the double bond here. Again, that will continuously happen a cyclic process, and that will give a very stable structure for this alkyl aryl halide. Understood? So you guys understood why does the aryl halides are so stable? Due to the resonating structures of these allobenzenes. Clear?
Yes, sir.
Okay. So then how can we do the reaction for the aromatic compounds? How can you do the nucleophilic substitution reactions, SN1 and SN2 reactions for aromatic? What are the conditions they need? Okay. So these these aryl halides, they can be remarkably reactive for nucleophile if you maintain few conditions. That is, when they react under the proper conditions. I'll tell you what are those proper conditions. Next one, when they bear certain substituents. So you give certain substituents in the reaction, then they will proceed with the reactions. So remember, these aryl halides, they can show the remarkable reactivity if you meet certain conditions. Otherwise, it will not react with the nucleophiles if you maintain the same conditions that you have maintained for alkyl halides. So one such condition is, first, you need to maintain certain proper conditions that matches for the aryl compounds, not for alkyl compounds. Second, when you use certain substituents. So let's see what is these. First, suppose Dawes process. Okay, in order to proceed with this nucleophile reaction, you need to eat the chlorobenzene, which is a aryl halide. You eat this aryl halide at 350 degrees Celsius under very high pressure. Okay, with a sodium hydroxide. So see here, what I said. So we need to maintain proper conditions. So here the conditions are maintaining 350 degrees Celsius with a high pressure. Second, I said certain substituents. So here I'm using the sodium hydroxide. So the reaction produces the sodium phenoxide. That means the benzene ring with OH group, okay, or ONA. And not only that, you should also do the acidification to finally get this phenol, the benzene ring with the OH. Understood? So that's how, by maintaining proper conditions, by maintaining certain substituents, you will be proceeding the aryl halides to undergo the nucleophilic substitution reaction. And those aromatic which are going with this nucleophilic substitution, you will call it as nucleophilic aromatic substitution. Okay. So let's see one of the example. How does this Dawes process happen? So let me take a benzene ring. I better draw the chemistry diagrams compared to the bio. Yes or no? So when you react this with a sodium hydroxide to NaOH under certain conditions, what are those conditions? Tell me. Just now I told you how much should be the temperature. 350 degrees Celsius and 300 atmospheric pressure, high pressure. So you will be getting the benzene ring with ONA. So what is this ONA? Sodium phenoxide. Not only that, you will also get NaCl plus water. Understood? So how does this chlorine is replaced with a ONA? Is that clear? So how does this nucleophilic substitution has happened? When you maintain certain conditions, like maintaining high temperature and high pressure. And when you take this ONA further, and what I said here, I need to do the acidification that will yield the phenol. So that means I'm taking this phenol, sorry, I'm taking this, what is this called? Sodium? What is this? Sodium? Benzene with O. We call it as phenoxide, sodium phenoxide. Okay. So when you are doing the acidification, that means you are treating with an acid. Here, the acid which we are taking is hydrochloric acid. So that will create a phenol. So benzene ring with OH, we call it as the phenol. Okay. So remember, this is the phenol. And you will get the sodium chloride as well. Okay. So this process is called as Dow's process, which is nothing but the aromatic nucleophilic substitution reaction. So if you maintain only these condition and particular substituents, then only this reaction will happen. Otherwise, it's not so simple like alkyl halides for undergoing the SN1 or SN2 reaction. Aromatic compounds, they do not simply undergo the SN1 or SN2 reactions. Only in particular maintaining the conditions and substituents, they will undergo SN1, SN2 reactions. Clear? And these SN1, SN2 reactions, they are slightly different compared to the alkyl halides. We'll see how they are different. So understood what is this Dow's process? How we have done that?
Yes, sir.
Okay,
Yes, sir.
Sharon understood. What about the others?
Understood, sir.
Saying yes also is very lazy for you all. శ్రీకర్ గారికి అయితే చెప్పవసరం
Yes,
లేదు.
sir. I
పెద్ద
told,
కష్టడు.
sir, I told yes, sir.
కొంచెం గట్టి చెప్పరా. నేను అంత మెల్లగా చెప్తే నీకు ఏమైనా అర్థమవుతుందిరా?
No, sir.
I'll say like this. Dow's process. Chlorine react with NaOH at 350 degrees Celsius. ఇలా చెప్తాను రా, ఓకేనా నీకు?
No, sir.
కొంచెం గట్టి చెప్పండి రా. ఏ తినట్లేదా? ఇంట్లో ఫుడ్ పెట్టట్లేదా?
అదేం లేదు, sir. Not like that,
చెప్పు,
sir.
లేకపోతే నేను మా మమ్మీతో మాట్లాడతాను. ఫుడ్ పెట్టట్లేదు కదా, మీరు పెట్టట్లేదంట, వీడు సరిగ్గా క్లాస్లో మాట్లాడలేకపోతున్నాడు, ఎనర్జీ లేదని చెప్పి అడుగుతా.
Nothing like that, sir.
So nucleophilic aromatic substitution. So here, if you see the other thing about this SN reactions in the aromatic, they undergo the addition and elimination mechanism, which we haven't seen for the aliphatic compounds like alkyl halides. So how does this happen? First, suppose let me say, first it will undergo the addition and it will undergo the elimination, and finally it form the nucleophilic substitution. So for suppose, let me take an example here. So there is a benzene ring that is attached to some halide, and let's say some other group is also attached here, the NO2. So when a nucleophile is attacking, let's say the nucleophile here is OH minus. So when this nucleophile is attacking the chlorine, the halide, it will undergo the addition process. So this will happen like this. And remember, this process is somewhat slower. So it's a slow process. So here it is adding here. The nucleophile is adding here. So that will look somewhat like this. So there is a benzene ring with a chlorine. See, at this point, still the chlorine has not left the benzene ring. Okay, still it is attached. But whatever this OH is there, it will also attach. and there will be NO2 is present here. If you extend this structure of NO2, it will look like this. I'll tell you why I'm extending this. So this act like the electron withdrawing group that will be very helpful for creating the resonance here to make this compound stable. Okay. So after forming this, whatever, if you see this carbon, it is holding the extra number of electrons. Already it had formed a double bond here. Again, it is attached to OH. Again, it is attached to chlorine. Now it is having 5 bonds. That is not possible. So it will try to break the bond with the chlorine. So chlorine will just not break the bond. It will take away the electrons. That's why I show the bond like this. That means the chlorine is taking away the electrons that are present on this bond. See, whenever if I am showing something like this, that means A is stronger electronegative compared to B. So as it is stronger electronegative, it will take electrons, the pair of electrons with it. Okay. So whatever the electron that is involved, for suppose one bond means 2 electrons. So whatever the 2 electrons are there, it will carry away with this A. So that's what it means. So that's why the chlorine will remove like a Cl minus. Okay. So this is the addition process. Understood? Now this will further undergo the elimination. See, this is very easy process because the chlorine, this structure is very unstable. So whatever the next process that's happening, it is very fast process. So the elimination is very fast. Understood why it is fast? This is slow because the attaching of the OH is not easy because already the carbon is very stable. Already it is consumed with all the 4 bonds. Then again you are attaching the 5th bond. It is not easy. But somehow you are doing so. It is a very slow process. But removing this chlorine, which is burden to the carbon, it's very easy. So this step is very fast. Okay. So that will result in formation of the benzene with OH and NO2. And whatever the chlorine is left, it will leave like a Cl minus. Understood how this happened? So this is how a nucleophilic mechanism. So this is SNAR. That means substitution nucleophilic aromatic reaction. So this is SNAR mechanism. So understood how this SNAR mechanism has happened? Any doubts?
Yes, sir. No, sir.
Yeah. So if you see here, there is a NO2 that I extended. Why I extended is this is acting like a electron withdrawing group. Okay. So which is why it is making this structure stable. So that's why I extended here. Understood? So here the carbocation is stabilized. That means when it is forming a carbocation, due to the electron withdrawing group, the position of ortho and para to the halocene atoms. So for suppose you can see here, so how it is happening. For suppose after attaching, there is a minus charge is produced. It is a carbocation, but we need to neutralize it because I said the carbocation for the aromatic compounds is very reactive, very unstable. Okay, aromatic compounds, the cation is very unstable. In order to stabilize that, it is undergoing the resonating. And that resonation is possible because of this withdrawing group. So that's why it is very, very important. Understood so far?
Yes, sir.
Okay. So remember, this is a carbo anion. So usually it should be carbocation, but due to the negative charge present, so this act like a carbo anion because you can see here the positive charge is present. So usually how it should be, carbocation means it should be the positive charge, but here it is containing the negative charge. So this is a carbo anion. Understood? So whenever the chlorine removes, it will turn out to be a positive charge. So which is a very unstable, but you got the negative charge here. So because of this resonance, you are stabilizing the structure. Clear?
Yes, sir.
Yes, sir.
Yes, sir.
So just remember this one thing. So carbo anion is stabilized So the carbanion is stabilized by electron withdrawing group in the position of ortho and para to halosine. So you can see here. So this is para, meta, ortho. Yes or no? Any doubts? Or is it clear? Can we go next? So
Yes, sir.
this is what the Sn reaction happens. So no, is it clear, right? The Sn reaction?
Yes, sir.
Okay. Now let's go to the electrophilic substitution, which is the second one. So let's see how does this electrophilic substitution happens in haloarenes. The general reaction, it somewhat looks like this. So you take a benzene ring, which is containing certain halosine. When you are putting some electrophile, this electrophile will replace this halosine. So it will attach and halosine will be removed. Okay. And remember, most of the allo groups are either the ortho or para directors. That means they will make the other groups to attach in the ortho position or para position. Remember this. So allo groups, they are ortho or para directors. I'll show you an example. So what is this mean? Ortho para directors means. First, suppose let me take reaction. You take a benzene which is having chlorine and react with a electrophile that's also another chlorine. So in the presence of anhydrous FeCl3, so this will be forming two different compounds. One is the benzene ring containing the chlorine. So whatever the other chlorine attaches, it could be either here or either here. So either it will attach here or it will attach here. So remember, this will be the major, this will be the minor. Understood?
Yes, sir.
So see here, what I said here, it's a ortho or para. So which one is para position? Tell me. This one is para, this one is para, or this one is para? So which one is 1, 2, or 3?
3.
Hmm? Which
Three.
one?
3
3. Okay. So this is. And what about this?
ortho.
Yeah. Okay. So remember, this one is major. The para position is major. Remember that. So let's see some of the other examples. So whenever the benzene ring with the chlorine, when you react with HNO3 in presence of sulfuric acid, so the reaction could form two compounds. So tell me which one will be the major and which one will be the minor. So this one will be major or minor?
Major,
Nitya?
sir.
Major.
Okay. This is major and this will be the minor. Mandara, అర్థమవుతుందా? Sorry, you are understanding?
Yes, sir.
Okay, don't answer. Now Mandara will answer this. As she said yes. So when it reacts with H2SO4, okay, I'll make you easy. So here one will be the chlorine. So tell me what will attach now. When it reacts with H2SO4, what will attach here? So see here, you can see here. For suppose if you have taken the HNO2, it attaches the NO2.
SO4, sir.
When you have taken what will attach here?
Mm.
H2SO4.
So SO4.
So what is attaching here? A nucleophile or electrophile? What is this reaction name called? Electrophilic substitution. That means what is attaching? The electrophile is attaching. So what is the first electrophile that will be formed from the H2SO4? H plus HSO4 minus. So tell me, will H plus will attach or HSO4 minus will attach? I made it very simple.
H plus.
Super. Write this reaction 3 times tomorrow and show it to me. So actually it is HSO3. Wait, is it 3 or 4? Okay, so see what happens here is H2SO4 is there. So it will break down into H plus SO4, HSO4 minus. Okay, so again what happens is whatever the oxygen is there, it will also break and it will turn out to be HSO4, HSO3. Okay, and here H and O, and whatever the when you are attaching here, it will also liberate certain hydrogen here. Yes or no? Otherwise it cannot attach to the carbon. So there should be one hydrogen will leave from here. So that hydrogen will attach here. So that will eliminate like a water molecule. Understood? So how does this HSO4, HSO3 is attaching here? See, I'm not explaining the detailed mechanism, but just remember, because for all the reactions, you don't need to know the detailed mechanism. Just understand. Understood how this happened? So whatever the H2SO4 is there, it will leave the proton and it will leave one oxygen, and that will convert into HSO3. Okay, and this will attach here. Whatever this H and O has liberated, so that will turn out to be hydroxyl ion, and whatever the hydrogen that is leaving here, that will be H plus, which will form the water molecule. Is this clear?
Yes.
Any doubts? Nitya, Mandara, Shrikar?
No,
Mm.
sir.
Okay. So see this one. This will be the major product and this will be the minor product. So tell me what happens here. So in CS3Cl, which one will be the electrophile? Cl or CS3?
Cl
See, what is meaning of electrophile?
positive.
Cl is positive when it break the bond with CS3. So when you break the CS3Cl, it will turn out to be CS3 plus Cl minus. So what is meaning of electrophile? The one which attracts the electrons. In order to attract the electrons, it should be positive or negative. Come on, guys, tell me. If I am saying electrophile means electron lover. That means it is attracting the electrons, which are negative charges. In order to attract these negative charges, should it be
Positive.
positive or negative?
Positive.
It should be the positive. So which one will attach? CS3 or Cl?
CS3.
Yes.
So, but the last reaction, I guess H was plus, right? So could you just go to the last reaction once?
This one, right?
Yeah.
So actually, after leaving the oxygen, this will turn out to be positive. Okay. When it releases the, for suppose H2SO4, when it releases, it will turn out to be H plus, HSO4 minus. But when it is leaving the oxygen will carry the electrons. So that's how it will turn out to be HSO3 plus. Understood? I didn't tell that, but yeah.
Yeah. Yeah.
Clear? Any doubts?
Yes.
No,
No, sir.
See, oxygen is it will carry away the, uh, like a O minus. And whatever the H is liberated, it will be like this. And it will also take another H that will turn out to be water molecule. So that's how it is a positive charge and that will attract. Otherwise, the hydrogen has to attach. Clear?
Yes, sir.
So tell me what will it form here? There's a benzene ring which contains the chlorine. There is
CH.
a benzene ring which contains the chlorine. Now who will attach here? CS3 or H or
CH.
Cl? CS3 or Cl?
CH3.
CS3. So which one will be the major and minor?
The first one is a major, second one is a minor.
Yeah. See, instead of explaining all the questions, I am just giving some good number of examples. CS3COCl. Now tell me, how does it will form? Tell me, how does the bond will break here? CS3. Okay, I'll draw the structure. First, suppose this will be like this: CS3, C, double bond O, Cl. So where will be the bond will break? Here or here or here? Which one is easy to break the bond?
Chlorine.
Here. So that will turn out to be CS3, C, double bond O. As chlorine will take away the electrons, so this will be the positive charge. And chlorine will be the negative charge. Now this will attack the benzene group. So the reaction will happen like this. So Cl and there is a Cl. So first it will attach here. So this is C because this C will go and attach here. And it contains CS3 on one side and it contains double bond O on the other side. The same way here. It attaches to the C which contains double bond O, CS3. So which one will be the major and minor? You guys know that. So this will be the major. This will be the minor. Mandara, understood? Any doubts?
No, sir.
Okay. So that's it. So let's see what is this Uj fatigue reaction. Guys, I'm telling you, there are 30 to 35 named reactions. At least some above 5 reactions, the named reactions will come. You can expect more than 5 or more than 10 as well. Some 10 to 15 marks for the board, only the named reactions. They'll simply ask, so what is Sandmeyer reaction? What is Wurtz fatigue reaction? Or they will simply give the example and ask you to do the product. What will be the product? Like they will give something XYZ and it will react and it is gives A and they will give AlCl3 and they will give B and they will give something else. They will give C. They will ask you what is this ABC, which reaction it will come under, like that. So named reactions are very important for the chemistry. And if you read all the named reactions, it's very difficult. So right now itself, I'm telling you every day few named reactions, you learn them. Already so far, I think 3 or 4 named reactions I told. Yes or no? Yesterday we talked about this Grignard reagent. So today, which fatigue reaction? So it's very simple. Let's see an example. So you take a benzene ring, which is having the halocene. So this benzene ring, and there is a alkyl halide. So if you see here, what is this? This is a aryl halide. Yes or no? And what is this? This is a alkyl halide. And what is this middle? A metal. That means whenever an aryl halide, alkyl halide reacts with a metal, they will be forming. So whatever this alkyl halide is there, this will go and attach here. Remember this. So it will form the benzene ring with alkyl group attached over. Okay. And whatever this Na is there, and here there is X and here there is X. So those X will combine with the sodium. So this X and this X will combine with the sodium, which will result in formation of 2NaX. Understood how this reaction happened? So that's what. So whenever there is a mixture of an alkyl halide and aryl halide with a sodium or treated with a sodium, it will give alkylated aromatic compound. You see here, it's aromatic compound which is attached with a alkyl group. So that's called the alkylated aromatic compound. Understood what is meaning of Wurtz-Fittig reaction? So it is very simple. Wurtz-Fittig reaction means you take a aryl halide, you take a alkyl halide, you react with the sodium. So whatever this alkyl group is there, it will replace this halogen. So that will turn out to be alkylated aromatic compound. And whatever the sodium halogen is there, it will form 2NaX. You can take like 2NaCl, 2NaBr, 2NaI. Okay. So whatever, it could be the fluorine, chlorine, bromine, iodine. Any doubts? See, if you understood this Wurtz-Fittig reaction, there is another named reaction, which is Damisi. So simply you can understand two reactions here. So the other one is Fittig reaction. So what you have taken here, you have taken aryl halide and alkyl halide. What is the difference between the Wurtz-Fittig and Fittig is, here you have considered aryl halide, alkyl halide. Here you will be considering only aryl halide. That means you take a two aryl halides. Treat with a sodium. So whatever this halogen is there, it will break and this will go and attach to here. So that's how it happens. So see here. So there is a two phenyl groups that are attached together. You can call it as the biphenyl. And whatever the Na, X and X, that will turn out to be 2NaX. And remember, we also use certain reagent here. That's a dry ether. In presence of dry ether, you are doing this. See here. So aryl halides, you are taking two aryl halides and react with a, see, both should be analogous compounds. Okay. So when they are treated with a sodium in dry ether, so sodium in the dry ether, so the two aryl groups will join together and form the biphenyl and sodium halide. Okay. Clear? Any doubts? Here also, I forgot to tell, here also it's a dry ether. Okay, in presence of dry ether, it happens. So the mixture of alkyl and aryl in with the sodium in presence of dry ether, it will give the alkylated aromatic compound. That's a Wurtz-Fittig. And if it is simply plain Fittig, that means you are taking two different, two homologous, two analogous. Analogous means the same. Okay, aryl halides and treat with the sodium in presence of dry ether, it gives biphenyl and sodium halide. So whatever the phenyl groups are there, they will be joined together. So that's what the Fittig reaction means. Any doubts? Or is it clear?
Clear.
Okay.
Yes.
Yes, sir.
So next one, polyhallogen compounds. So what do you mean by polyhallogen? What is meaning of poly?
Many.
Halogen. That means different halogen groups. So that means a carbon that contains different halogen groups. Like you can see the carbon with the chlorine, fluorine, fluorine, chlorine, which acts. Okay. Or you can take chlorine, 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 hydrogen. Okay. Trimethyl. This is called as the trimethyl. Sorry. This is called as trichloromethyl. As there is a three chlorines and there's a one carbon, so it's a trichloromethyl. It is a difluoro-dichloromethyl because two fluorine and two chlorine. So see few examples of the polyhalogen compounds which are given in your textbook. So dichloromethane, trichloromethane, triiodomethane, tetrachloromethane. We'll be studying all of them. They are important. So what is their use? What are the side effects? What are the risk of these if you get contact with them? Freons, and finally DDT. So these are the different compounds that are given. So what we'll do is first we'll see what is their structure. We'll see what is their use and what happens if you get in contact with them, like they're poisonous. Okay, if by or wanted if you consume it, what happens? So what are the harmful effects? We'll see. Okay, so these are chloromethane. That means how many chlorines are present?
Two.
So there will be two chlorines and the other will be hydrogens. So which is nothing but CH2Cl2. So this is called as the dichloromethane. So how do you use this dichloromethane? So what are the uses? So for painting remove, so it is useful. So they can give. So what are the uses of this for IP for board exam? It could be helpful. So paint remover, it also acts like a propellant in aerosol. It can also act like a metal cleansing. If you find any other other uses, just add on. Okay. So these are the few uses of this. And what are the harmful effects or what will happen if you directly come in contact with these? So harmful effects. So the harmful effects are uh, it can cause the slight hearing and vision impairment. So hearing and vision impairment. So when they are come in contact with you. So there will be tingling, numbness in the fingers and toes. You know, right? Tingling. So that means your toes and all, you feel like something is poking them. Or you feel like no sense. That's a numbness. So that could happen when you sit for longer hours. So tingling and numbness for the fingers and toes. You can feel the vomiting feeling, so nausea. You can also see there's a harmful effect on the CNS. So harms the central nervous system. Okay, so these are the harmful effects. And what happens when you come in contact? Okay, direct contact. So it can cause the, like for suppose you are doing in the lab and if you expose to this on your skin, so it can cause the burning sensation and it can also cause the inflammation there. So there will be mild redness as well of skin. If it comes in contact with the eyes, that will burn your eyes. So burning of cornea. So these are the things that could happen when you direct contact with them. Okay. So next one, trichloromethane. So trichloromethane, that means how many chlorines?
3.
Three chlorines with hydrogen. Okay. So what are these uses? So if you see their uses, they can act like a solvent. So they can use like a solvent for fats. So fats in the sense you can take the lipids. Okay. So fats, alkaloids, iodine. So all these can be soluble in this. Next one, it can also useful for the production of the freon. I'll tell you what is this freon. It's also one of the polyhalosane. So it will be useful for production of freons. Remember, these freons, they are used in the fridges. So they act like a refrigerants. Especially in that there is a some type that's called R22. That means based on how many fluorines are present. So, and it can also be useful as the anesthetic during the surgeries. So anesthetic in surgery. Okay. So what happens if you are using excessive? So the harmful effects. So the harmful effects of trichloromethane, it is it causes the dizziness, fatigue, headache. You know, right? All these. We discussed them in the biology, health, and I mean when we talked about the drugs. So it can also damage the liver and kidney. So these are the harmful effects. I know these might not ask, but just remember they can give a questions like what are the harmful effects of trichloromethane? You should be able to use. So just know two points. And there is a this one could be important. So actually it can cause a poison. Okay. So there's a harmful effect of this trichloromethane, that is when you react this trichloromethane with the oxygen in the presence of light, it could turn into 2COCl2 plus acid. And if you see this COCl2, this is called as the phosgene. Remember this. So this phosgene is a very, very, very poisonous gas. So it is a very poisonous gas. Remember this. So whenever you treat this trichloromethane with the oxygen in presence of light, that means when it will directly expose to the atmosphere and in presence of light, that can turn out to be phosgene. So that means it should be present in the container and tightly packed. It should not leak out. But somehow, whenever the container gets damaged and if it is leak out, and there, atmosphere contains the oxygen and its sunlight falls on that, it can turn out to be this gas. And whoever that present in that area, they will be highly affected with poisonous gas. So that's how so many accidents used to happen in the factories, chemical factories. Okay. So this phosgene will be released. So that's why they will safely put in some containers and tightly pack it. Understood?
Yes.
So next one, triiodomethane. That means it contains three iodine groups. Triiodo. So iodine, iodine, iodine. Okay. So why do we use? Have you ever heard the ointment betadine? Betadine ointment or iodoform ointment. That's nothing but useful for antiseptic. So whatever the betadine or the brown color ointment, whenever some wound is there, you apply that. So that's nothing but this triiodomethane. So which acts like a antiseptic. Okay. So that's showing antiseptic because of the properties of the liberation of free iodine. So they liberate free iodine. And this iodine will kill the microorganisms. So that's how it is acting like a antiseptic. Next one, tetrachloromethane. So that means all the carbon is attached with chlorine. See, the carbon is attached all the bonds with the chlorine. So that's a tetrachloromethane. This tetrachloromethane, one, they will be helpful for manufacturing the refrigerants. So manufacturing, you need to remember all these things for the final exam, even in NEET. So manufacturing refrigerants and propellant for aerosols. So propellant for aerosol cans. That means whatever the spray you are using, in order to push it, they will. For suppose you take some spray, which is a perfume. So some percentage it will be perfume, some percentage it could be some of these gases. So whenever you are flushing it, the air will come out. That's because of this propellant nature of this tetrachloromethane. It can also be useful for chlorofluorocarbons. So whenever you want to synthesize the chlorofluorocarbons, you can use this tetrachloromethane. So whatever the chlorine is there, it will be replaced with the fluorine. That will turn out to be chlorofluorocarbons, which could be useful for the refrigerants. Okay. And it's also useful for pharmaceutical industries. So pharmaceutical manufacturing for making certain drugs. So useful for synthesis of, or you can say it is the feedstock in synthesis of chlorofluorocarbons. So what is the uses of this? Other uses, it could also act like a cleaning fluid. So see other uses. These are all industrial uses. If you see other uses, it can use like a cleaning fluid. It can also use like a degreasing. That means whatever the grease you applied in order to remove that, so it acts like this. So degreasing agent, and it also acts like a fire extinguisher. So fire extinguisher. So these are the uses. Then what are the harmful effects? See, this will damage the nerves. So nerve cell damage, it can cause cardiac arrest. If someone breathe this, their heart stops. So cardiac arrest. It can also cause the liver cancer if they exposed to small traces of this. Okay. Not only that, when the person comes in direct contact, so that could cause the dizziness and lightheadedness. It can also trigger the nausea that could cause the vomitings. Okay, so these are the side effects of tetrachloromethane. Next one is freons. So what is this freons? So what is this freons is? It's nothing but the chlorofluorocarbons. Chlorofluorocarbons of methane or ethane. That means you take one carbon that is attached to the chlorine or fluorine. I mean, attached to both the chlorine and fluorine, or you take a ethane that also attached with chlorine or fluorine. Okay, so that collectively called as the freons. So chlorofluorocarbons of methane and ethane, collectively we call this as the freons. So you can see example like this. So carbon, chlorine, fluorine, and fluorine. So you can see here, there's a two chlorine and two fluorine. Difluoro, methane. Okay. So what are the uses of this? I told you. So mainly it will be useful for refrigerators. I told you here. Yeah. Mm. So production of the freons, which acts like a refrigerant. So that's one. So the main uses of especially the freon 1, 2. That means the fluorine present on two fluorines were present. If there are only one fluorine is present, it will be like 1 comma 1 or something like that. Okay, so just know freon 1 comma 2 means this one. Okay, so aerosol propellants, it also used as aerosol propellants, especially they are useful for refrigerators as a refrigerating unit, and they also used in the air conditioners, ACs. Okay, and if you see the freons, so why, you may have questions, we are using them in the ACs and fridges, so are they harmful? Actually, these are stable compounds, mostly non-reactive and non-toxic, and they can be useful in the liquefiable gases. You might have seen, they say, so the AC is not working, it's not giving the cold wind, cold breeze. That's due to the liquid in the AC is over or the gas is over. We need to refill that gas. That's mostly this freon. So it's a liquefiable gases which will cause that coolingness. And remember, these freons, they are not harmful to us. But whatever the ozone layer that's depleting, that's because of the refrigerants. That's this dichloro-difluoromethane. That's nothing but this freon. Okay. So remember, in stratosphere, where the ozone layer is present, so this freon, what it is doing is, it is causing the radical chain reaction. Okay, so it initiates the radical chain reaction. Actually, what happened, the ozone reacts with a free radical of oxygen and turns into the ozone, but due to this freon, the cycle was happening reverse. So whatever the ozone is there, it was depleting to the oxygen and oxygen radical. So due to that, whatever the ozone layer is there, it is decreasing and it is creating the oxygen. So due to that, the ozone layer was depleting. So remember, due to the freons, the ozone layer depletion happens. That's due to initiation of the radical chain reaction. So which will cause the hazard to the nature. Okay, so that will cause imbalance or it will upset the ozone balance in the nature. So imbalance the ozone, or you can say imbalance natural ozone. Okay, so this will affect the nature's ozone balance, or it will upset, it will create the imbalance to the nature's ozone. Okay, so that's about the freons. Next one, lastly, it's a DDT. So as Shrika said, we done this. It's nothing but dichloro, diphenyl, trichloro, ethane. Okay, so dichloro, diphenyl, trichloro, ethane. So many, so if you see the structure, it looks like this. There will be benzene, the carbon. So this is a dichloro, diphenyl. You can see here, dichloro, diphenyl, trichloro, ethane. Two carbons are there. Okay, understood how it is called as dichloro, diphenyl, trichloro, ethane. It is nothing but C14H9Cl5. Okay. So remember, whenever someone consume this, like the humans, okay. So whenever the harmful effects, whenever a human who consumes this, it is not metabolized very rapidly in the liver of the person, okay, or the liver of the animals. So DDT, not metabolized very rapidly by animals. So as it is not metabolized, it will be stored in the body itself. So either it will be deposited in the fatty tissues or it will be stored in the fatty tissues. So deposited in the fats like in your skin and all, or in your liver. So deposited and stored in the fatty tissues. If it is metabolized, then it could send out through the urine or through fecal matter, but it is not metabolized, so it cannot send out. So it will be somewhere stored in the body, that's in the fatty tissues. Okay, so that's about the alloalkenes and alloarenes.